All right, today we're going to dive into a challenge that, well, it keeps pretty much every sound mixer up at night.
Oh, exactly what you're talking about.
How do you send absolute professional-grade audio over, I mean, truly massive distances? We're talking stage to control room when copper cables just can't do the job.
Exactly. When you need broadcast quality over 2, 5, even 20 kilometers, you just have to stop relying on electricity and start relying on light.
And that's our focus for this deep dive.
Right. We're looking at the Thor Broadcast F-4A-XLR-B-PHP-TXRX. It's a fiber optic converter built for this one specific task.
And the mission is to figure out the tech that makes 20,000 meters sound exactly like 20 feet.
It's pretty amazing stuff.
So let's start with the basics. The spec sheet says 4 channels of bidirectional XLR analog audio. That bidirectional part seems really central for, a live stage environment,
Oh, it's crucial. It simplifies all your monitor and talkback routing. And just as important, it includes 48 VDC phantom power.
which is non-negotiable for professional condenser mics.
Absolutely. You need to power those mics right at the source. But the real game changer is how it moves the signal. An analog XLR run just falls apart after a certain distance. This converts it to light, sends it down single mode fiber, and gets you up to 20 kilometers.
Okay, but that raises a question for me. If we're already moving the audio digitally, why are we using a dedicated box like this instead of, just using IP audio protocols like Dante over standard network switches?
That's a great point. And while IP audio is fantastic for local networks, these systems are really optimized for point-to-point integrity over extreme distances.
Ah, so for places where you might not have that full network infrastructure.
Right, or where you need absolutely rock-solid, zero-latency clocking that a standard enterprise network might struggle to guarantee across, a vast physical run.
Okay, so running 20 kilometers is one thing, but guaranteeing the signal purity without those digital timing errors, that's another challenge entirely. How do they fight interference and jitter over that kind of distance?
This is where the technology gets really specialized. The core integrity comes from using FPGA digital code.
So a custom processor just for this task.
Exactly. It's tuned only for audio. And that's paired with some really sophisticated clock recovery technology, which basically regenerates a perfect timing signal and just eliminates jitter completely.
And what about noise?
Well, the spec lists a 100 dB signal-to-noise ratio, which is extremely high. It gets there with an intelligent noise reduction system.
What does that mean in practice?
Instead of a hard gate that clicks on and off, it uses these soft rising and falling ramp waves. So when you plug or unplug a mic, it gently fades the signal in and out. No pops, no clicks. It's seamless.
And that's on top of the 24-bit AD sampling at 192 kilohertz.
Yeah.
So the fidelity is there. But what about physical robustness?
Oh, it's definitely built for the real world. It has level 3 lightning protection on the audio interface. And what's really fascinating is an automatic high-pass filter that isolates any DC offset.
Unwanted current that could corrupt the signal.
Right. It's just protection at every single level.
This feels almost too robust, too standardized for just 4 channels of audio. Looking at the bigger picture, this seems like it's built for a whole production environment.
And that is the critical takeaway. The equipment uses something called CWDM technology, coarse wavelength division multiplexing.
Which means?
It means you can add video, data, network signals all onto that same single fiber strand with the audio.
Wow, okay, so each signal gets its own color of light, essentially.
You've got it. You're collapsing multiple cable systems, video, network, audio, all into one optical run. It allows for centralized management, plug-and-pull cards, often in a big 4U rack chassis.
This isn't just a converter, then. It's part of a whole broadcast backbone.
Precisely. And it's proven with a projected working life of over 100,000 hours. It is, by definition, future-proof.
So to wrap up our deep dive, we're looking at a system that sends high-fidelity analog audio across 20 kilometers by using dedicated digital clocking and extreme noise reduction.
And that leaves a pretty important question for you to think about. If a single fiber optic cable using this CWDM tech can handle 4 audio channels, plus all the bandwidth for video, for data, for networking, how quickly is light replacing every other form of signal transmission in professional settings? What other data streams are being squeezed onto those same beams of light that might have just started their journey powering a single microphone? Something for you to mull over.